Welcome back. So conic sections part 2. We're going to do circles and ellipses today because circles are very short. It's a very quick lesson. And circles and ellipses are very similar. So notice for a circle, we got to talk about the anatomy again. Circles are very simple. All they have is a radius and a center. My apologies. A center, and the center is a point that has an x-coordinate and a y-coordinate. This is the only one of the four, parabolas, circles, ellipses, and hyperbolas, that has one equation. All the other three has one for horizontally oriented and the other for vertically oriented. So circles are nice. Here's the equation of a circle. So this is obviously the radius here, and these are coordinates of the vertex, right? So you have the x goes here and the k goes there. Don't forget to switch the signs. So this is very streamlined. Let's do an example. I'll just put it up right here, right next to it. We all know what a circle looks like anyway. Let's say, here's the equation, and now over here is an example. Example 1. Okay, so the radius has got to be 5, right? Notice in the equation that r is squared. So if I see a 25 there, that is r squared. So in this case, the radius is 5 units. The center is going to be at -3, 4. The x with the x, the y with the y, switch the signs, and that's it. And those are the only two things we need to know for a circle. So if I put this on a graph, I go back 3 and up 4. Oh, see, I'm going fast, not being careful. I didn't leave myself any room. Two, 4, 2, 4. So I'm going to go by 2s now, because I noticed my radius is 5 units and I got to be able to fit it in there. So if I go back 3 and up 4, these are minuses, that would be the center. And then what I do for the radius is go left, right, up, and down, however far the radius is. So I'd have to go up 5, and my scale's by 2s now. 2, 4, 5 up, 2, 4, 5 down, 2, 4, 5 left or right. Where am I? 2, 4, 5 right. And then try to make the best circle you can. I'm going to cheat because this is a crudely drawn hand graph. But see, if you do 5 up, 5 down, 5 left, 5 right, you can get a pretty good circle there. All you got to do here is label the center, and we're done. Like I said, circles are nice. They're short and sweet. Let's do a couple more examples to make sure we have it locked down. So we'll do, how about a blend, and then here, we'll do this one. And this one. Okay, so this is pretty regular looking. I know that I have a center at -1, -2. Furthermore, I know the radius is 3. So if I put this on a graph, I have to go back 1, down 2. That's my center. And then for the radius, I'm going to go up 3, 1, 2, 3, down 1, 2, 3, 1, 2, 3, 1, 2, 3. And then just make the best circle you can going through those dots. Kind of shaky. Right, for this one, why is there nothing here? This looks different. This is like x minus 0 squared. So my center would be 0, 3, 0, 3. My radius is 1. So if I graph this, bad placement, I have, sorry about that. I'm all cramped in here. Let's just erase this. All right, here we go. Okay, center, it's 0, 3, but my radius is 1. Up 1, down 1, left 1, right 1. Make the best circle you can, and there you go. And you just label the center with a C. Okay, so hopefully that's not too bad. Circles are, it's very similar to what we were doing, and there's only one equation. But now we got to shift to ellipses. And that we're going to have to start with the anatomy again. So conic section, ellipses. And we've got two types. This type and this type. Vertically oriented, horizontally oriented. So what are the body parts of an ellipse, right? An ellipse is like an oval shape, kind of. Well, there is a center. And that would have coordinates, x and y. And then there are two focuses. We say foci or foci. I hear it pronounced both ways. So they'd be somewhere like that. I got to do a little more explaining. Then we have what's called so focus 1, focus 2, focus 1, focus 2. We have two vertexes, also called vertices, V1, V2. And now we have something new called a co-vertex, and that would be right here and here, and we'll call that CV1 and CV2. So there's a lot going on here. CV1, CV2. Furthermore, if you look at an ellipse, there's what we call a major axis that's the major axis, and a minor axis. Right? Major is the long one, that's why it's called major. Minor is the short one, that's why it's called minor. Now we're going to have three letters here. We're going to have an A, a B, and a C. This gets very cluttered. Actually, let me do that on this one. So we got the green, which are the body parts, and then the red letters are letters that fit into the equation. So let me tell you what we're seeing here. A is the distance from the center to the vertex. B is the distance from the center to the co-vertex. And C is the distance from the center to the focus. So let's look again with that in mind. A is how far it is from the center to the vertex. B is how far it is from the center to the short end, the co-vertex. The center to the short end, the co-vertex. And then C is the distance from the center to the focus. It's actually either one. These are the same distance. It's symmetric. So C would be so many units this way, so many units that way. So we have those three players going on. So I know that's a lot to take in, but let's work through a couple examples. I got to give you the equations still. So you need this. Have that in your notes. Now I got to erase this, and I'm going to write the equations. For a vertically oriented ellipse, we have x minus h squared over b squared, y minus k squared over a squared equals 1. For a horizontally oriented one, x minus h squared over a squared, y minus k squared over b squared equals 1. Now look at those. Those are almost identical. So remember, A is going to be the distance from the center to the longer side, the vertex. See, A is always going to be longer than B for an ellipse, not a hyperbola, which is coming later. But for an ellipse, A is always longer than B is. What that means when you're looking at these, you're actually going to be seeing numbers in these. A will be the bigger number for an ellipse. So notice, if the bigger number is under the Y stuff, it's a vertically oriented ellipse. And if the bigger number is under the X stuff, it's a horizontally oriented ellipse, right? X-axis, horizontal, bigger number under the X. Y-axis, vertical, bigger number under the Y. That's the pattern. So you want those pictures with those equations. So, you know, at home you can like pause the video and record what you want. And now let's do some examples. Okay. So I know these are ellipses because I see the fractions, I see it equals 1, and there's a plus sign in between them, excuse me. Let's start trying to get information off of these equations. We'll just go one at a time. Here's our first problem. Try to ignore this one for the time being. Well, what do I notice? I notice that the bigger number is under the Y, so that is vertically oriented. Bigger number under the Y, it's going to open this way. That's my little note to self. It looks like an egg. It's a vertically oriented ellipse. Here, if this is better, it's that shape. Yeah, that shows up. Okay, furthermore, I know the center is going to be at 1, minus 3. X stuff with X stuff, Y stuff with Y stuff. Switch the signs. See, that's the same all the time. I also know that A is 2 and B is 3. And this is going to, you know what? We won't worry about the focuses. Given the circumstances, let's just get the ellipse and we won't worry about the foci. So if we just get these, we won't worry about C. Let's see what we got. All right, I have a center at 1, minus 3. Now, ooh, I got this backwards. A is the bigger number, and B is the smaller number. It's got to be. My bad, right? A is the bigger, B is the smaller. So what does that mean? Here's my center. I know it's got to be like this, so I have to go more up and down. 1, 2, 3. 1, 2, 3. And less side to side. Remember, this is the center. And if I connect those dots carefully, especially if I did on graph paper or I was a little more careful with my graphing, I would get an ellipse shape. So it's taller than it is wide. This is the center. The vertexes are on the major axis, the longer one, and the co-vertexes are on the shorter axis. I don't care if you call this one or which way. We won't worry about the foci. So let's try this one. I'll try not to mess up this time. I see it looks like an ellipse equation. I see the bigger number is under the x. That's going to be this shape. Furthermore, I see the center is at -2, -1. A is 5, the bigger number, square root. B is 1, the smaller number, square root. So let's try to make a graph here. So I have a center at 2 back and 1 down. I know it goes this way, so the bigger number goes forward and back. I'm going to need a little more marks back here. 1, 2, 3, 4, 5. 3, 4, 5. And then I got to go 1 unit on the short axis. Boy, that scale doesn't look at all right, does it? Five forward, 5 back, 1 up, 1 down. Forward and back, up and down, because this is oriented. Make the best ellipse you can. Label the center, your 2 vertices, your 2 co-vertices. If you call that V1 and that V2, that's fine, and we won't worry about the foci. Okay? So give those a try. If you have questions, send me emails or a message in Brightspace or comments on this video. And we got one more to go. Hyperbolas is next.